So for this video, we'll discuss the variety of functions that we can integrate. So relating this to what we have last time, we can only integrate polynomials in general, but now we can expand our vocabulary in integration, where we can also integrate exponential functions, logarithmic functions, and so on. So how do we solve this problems? Let's see through our examples. No? So what are the intended learning outcomes of this topic? So we have compare different formulas for integrating transcendental functions, evaluate functions by using different integration formula, and then derive the formula to be used in integrating transcendental functions. So we have an outline here. So we will discuss here first the integration involving exponential and logarithmic functions. And then later we will also discuss integration of hyperbolic functions and then inverse functions. Okay, so in differential calculus course, we already described how to find the derivative of an exponential function. So if you can recall, we have the derivative of a raised to u that is equal to a raised to u ln a du. Now for exponential, no, which is e raised to u. So natural number e or Euler's number, we have e raised to u du. So basically, the general formula is still this. Since if a is equal to e, then this will become ln e, and ln e will cancel out into 1. Ano? So that is why this is cancelled out when a is equal to e. Ano? So how do we now integrate a given function if it is an exponential function? So an exponential function, just to add a little bit, no? So the constant here is below, the variable or the function is in the exponent. No? So this is the exponential. And if we have a polynomial, we have a variable raised to a constant. So don't be confused with this two. And this is important. Ano? Okay, so now how do we integrate? So integration, we can integrate this, both sides. So this will become a raised to u is equal to the integral of a raised to u ln a du. So we know that ln a is a constant, guys. So ln a constant, or the natural log of a, natural log of a constant is still a constant. So therefore, we can see that a raised to u is equal to ln a integral of a raised to u du. So we can factor out this. No? So therefore, we can say here, no, isolating this integral, we can say that the integral of a raised to u du is equal to a raised to u over ln a. Okay, and then upon evaluation, if you evaluate this, we have to add an arbitrary constancy. Okay, so this is the integral of a raised to u du. For e raised to u, so we have this, so we integrate this both sides. So basically, that's it. So if we integrate this will cancel out. So we have e raised to u is equal to the integral of e raised to u du. Therefore, upon evaluation of this, we have to add an arbitrary constant c. Okay? It is that simple now, comparing this to differentiation. Okay, so another one is the natural log. No, if you can remember of u, the derivative of ln u is 1 over u. So therefore, if we integrate this again, so we have to cancel this d and integral. So we have ln u is equal to the integral of 1 over u du. No? So to simplify this, as you can see, actually this should be absolute value. Since u here should be absolute value, we cannot make this negative. So the integral of 1 over u du is equal to ln u plus c. Ano? So absolute value na to. Ano? And then we can also write this as u raised to negative 1 du is equal to ln of u plus c. Ayan. Okay. Okay, so let's have an example already. Ano? So let's say we have to find the integral of tangent u du. So how do we evaluate this integral? No? So to evaluate this integral, no, we do not have a formula. Actually, we have a formula for this, but usually it is not available, no, directly. Or it is hard to remember, no? So if you forgot the definition of this, we can derive for its formula. So we know the tangent u du cannot be integrated directly. We can try manipulating this. We can try rewriting this tangent u so that we can be it will be integrable. So we know the tangent u is equal to, so we have sine u over cosine u. Yeah. No? So as we can see here, the derivative of sine is cosine. The derivative of cosine is sine. So maybe we can use the u substitution. So for this one, I will just utilize, no, I can try utilizing u, or for this example, since u is already the variable, I can use v is equal to cosine u. Ano? So dv, no, the derivative of v here is negative sine u, du. Yan. So this will be equal to the integral of, we have to also remove this one. So du is equal to dv over negative sine u. So this will be equal to sine u over v multiplied by dv over negative sine u. Yeah. Okay. So to simplify this, we have the integral of so cancel this. The integral of dv over v, and then the negative sign here, we have negative dv over v. So what is the integral of this? The integral of this is ln. No? So if you can recall, we have ln of u plus c, that is equal to the integral of du over u. You know, or we can call u raised to negative 1 du. You know? So it has two variations on how to write this formula. So we have ln of the absolute value of v plus c. So what is v here? V here is equal to cosine u. Therefore, this is equal to negative ln cosine u. And then plus c. Okay. So actually, no, this is already the final answer, but we have an alternative way to show the answer here. So the properties of logarithmic functions, so if we have a negative sign here, actually we can distribute this inside as an exponent. So we have, we can rewrite this as ln cosine u raised to negative 1 plus c. So if this is cos raised to negative 1, no, so don't be confused with inverse, no? And raised to negative 1 here. Basically, this means we have ln of 1 over cosine u, ano, plus c. And what is 1 over cosine u? That is secant. So we have ln secant u plus c. Yeah. Okay. So we can utilize, or we can use this formula for solving our integrals. So the derivation, now we can see that we derive this one, but the other trigonometric functions can also be derived using the similar approach. Ano? Yan. Okay, so take note of this. So evaluate the integral. So we have an example to evaluate this integral. Okay, so we have a given here. So what should we do? So we don't have an direct integration of this function. But as we can see, upon inspection, if we find the derivative of x raised to the fourth, the derivative of that is in some way has a portion of x cubed. So the derivative of x raised to the 4 is 4x cubed. So we can cancel this probably. So we can utilize u substitution. We can let u is equal to x raised to the 4th power, find the derivative, and then find dx. So dx is equal to du over 4x cubed. So therefore, this is equal to x cubed e raised to u, and then dx is du over 4x cubed. Okay, so we can cancel out this x cubed. So we have 1/4. Okay, factor out this 1/4. And then the integral of e raised to u du. Therefore, the integral of e raised to u du, so what is that? So the integral of e raised to u du is e raised to u du, right? No? Plus c. So what is u here? So the final answer should be 1/4 e raised to x raised to the 4th power plus c. Okay, so that's it. Okay, next example. So we have this given integral. Again, we do not have a direct integration of this. But what can we observe here? So we can try letting this as u. No? If you let this as u, what is the derivative of this? So we have 0 minus e raised to x. No? So since this e raised to x and we have e raised to x here, we can probably use this substitution. So we can let u is equal to 1 minus e raised to x. And then du is equal to negative e raised to x dx. So dx is equal to du over negative e raised to x. So therefore, this will be equal to e raised to x square root of u. Okay, square root of u. And then dx is equal to du over e raised to negative x. Negative e raised to x. Okay, we can cancel this out. So we have negative sign. So negative integral of square root of u du. So when we have square root of u, we can say that this is u raised to 1/2. So this is equal to negative. So using the power rule, general power rule, we have u raised to n du. This is equal to u raised to n plus 1 over n plus 1 plus c. So we have u raised to 3/2 over 3/2 plus c. We can simplify this. We have negative 2/3. And then we can also change the u. So u is equal to 1 minus e raised to x and then raised to 3/2 and then plus c. So this will be your final answer. Okay. Okay, another example here. So we have 4 raised to t minus 2. So how do we solve this now? Okay, we have a formula for this. We have a raised to u. Du is equal to a raised to u ln a plus c. So a here, guys, no? So a here is constant. So now, how do we solve this? So a is a constant. Okay, we are good with that. But since this is t minus 2, we have to change this as a variable u only. No? So we will let u is equal to t minus 2. And then find the derivative, we have dt. So therefore, the integral is also equal to 4 raised to u. And then dx will now be dt. Okay? So, du pala, no? Du. So this will now be equal to a raised to u ln u. Ln a. So we have 4 raised to u. 4 raised to u over ln a. So a is 4, so ln 4. And then plus c. Therefore, no, changing this u again, we have 4 raised to t minus 2 over ln 4 plus c. That's it. It's that simple. No? Okay. So now let's evaluate this under integral. Okay, so what should we do here? We do not have an integral of this directly. We cannot simplify this now by dividing since this is two terms. Ano? We cannot simplify this as a fraction. No? So we should utilize here u sub. No? U substitution. So if we let u as this, finding the derivative, we have 2x plus 0. So 2x, we have x here. So we can probably divide this. No? So we have to let u is equal to x squared plus 1. So du is equal to 2x dx. Okay, so dx is equal to du over 2x. So therefore, this will be equal to x over u. And then dx is du over 2x. Ayan. Okay, so cancel this out. Factor this 1/2. So this will be equal to 1/2 du over u. So what is the integral of d over u? That is ln, no? So 1/2 ln of u plus c. Now, what is u? So going back to u again, we have x squared plus 1. So the final answer should be this. Okay, this is your final answer. Okay. Next example, we have this integral. Yeah. So we do not have again a direct integration of this. And then take note that this is a definite integral. So what should we do here? What shall we do here? Okay, so actually we can let this as u, no? We can let this as u. And then let's see, no? So if this is u is equal to 5x plus 1, so du is equal to 5 dx, no? Therefore dx is equal to d over 5. So solving this again, we have, so dx is now d over 5, and then all over u. So simplifying this first, we have 1/5. Now factor out this 1 over 5. So from 0 to 1 of d over u. Okay, we already know that this integral is equal to ln. No? So we have 1/5. We have ln of u. Okay, so plus c pa ba? So not plus c. No? So since this is a definite integral, we just have a limit from 0 to 1. And then you can change also the u. So this is equal to 1/5 ln of 5x plus 1 from 0 to 1. Okay, and then simplifying this, sorry, this should be, ayan. Okay, so simplifying this, sorry, dito ko nalagay, no? So we have 1/5, and then substitute the 1 first. So we have here ln, so 5 plus 5 times 1 plus 6. So we have ln 6, and then minus, we have ln, this will be 0, so ln 1. So what is ln 1? So ln 1 is actually, so ln of 1 is equal to 0 actually, ano? So the log of any base where a should not be equal to 0 of 1, that is always equal to 0, ano? I'll just make this b, ano? Okay, so this is equal to 0, therefore, the final answer is 1/5 ln of 6. Okay, so that's it. Okay, next example here. So we have this problem. Okay, this is intimidating at first, but it is actually simple, ano? So how do we solve this? So inspecting this, we cannot simplify this. No? We can just use, yes, we can just try using u substitution, ano? So if we try using u substitution for ln x, what is the derivative of ln x? No? So the derivative of ln x is just 1 over x. Ba? So remember your derivatives. So du and then dx here. So therefore dx is equal to du or x du, no? So cross multiplying, we have x du. So as you can see, you can cancel out this x, no? So this will be equal to ln x, u over x, and then dx is now equal to x du. So we can cancel this x here. I think I'll just write this here. So this will be equal to, we have 1 is to e. So we have u du. So what is the integral of u du? We have the power rule, no? General power rule, we have, this is u squared over 2, no? And then evaluated this from 1 to e. So simplify this, ano? So 1 to e. Okay? So from 1 to e, we have to change first this u into ln, no? So this will be ln. Actually, you can also change the limits, no, if you want. Either way, you'll achieve the same answer, no? So ln squared over 2 from 1 to e. So this will be equal to ln e squared over 2 minus ln 1 squared over 2. So this will be equal to, so ln e is equal to what? So ln e is actually equal to 1, no? Parang nagka-cancel out siya, no? And then ln 1 is, we know as 0. So this will be 1/2 or 1 squared, which is 1/2, and then minus 0. Therefore, this is 1/2. Okay. We evaluate the given integrals. So, what should we do this? What should we do here again? Again, no integral here. So we can try using u, no, to find the integral of this. No? We could let this as u. So u is equal to ln z. Find the derivative of ln z. We have 1 over z dz. So dz is equal to c du. Okay, so we can substitute now the u to this and this. So we have sine z over z, and then we have z du. Okay, so we can cancel out the z here. So this will now be equal to the integral of sine z. Sine z tuloy. It should be u, no? Sorry. So this should be u. So this should be u. So du, and then what is the integral of sine u du? That is just cosine u. No, positive or negative? Should be negative, and then plus c. So what is u here? That is ln c. So this will be negative cosine ln c plus c. Okay, it's that simple. And then the last one, we have the integral of cotangent x dx. Again, so recalling what we did last time, how do we integrate cotangent x? So we know that cotangent x is equal to what? No? We have cosine x over sine x. Ano? And then dx. So what should we do here? What shall we do here? We can let u as sine x. Okay? We can let u as sine x so that the derivative, no, of sine x is cosine x dx. Therefore, dx is equal to du over cosine x. Okay, so we have, I think I will. So this will be equal to cosine x over, we have here u, and then we have du over cosine x. So cancel this cosine x. So this will be equal to du over u. What is the integral of d over u? This is equal to ln absolute value of u plus c. So what is u here? Sine x. So therefore the final answer is ln of sine x. So actually you don't need to memorize the formula, no, for trigonometric functions, since you can actually utilize the trigonometric identities to derive for its formula. Okay, so that will be all for today. Thank you guys for listening.